using an inverse function? Yeah, sometimes you got to do that. So here, let me show you guys what it looks like. We have two different trig functions, which you guys know we can't do, so we got to switch one of them out. You guys remember the Pythagorean identity? Oh, I should probably show you the Pythagorean identity again. I know you guys are not sick of seeing this. You guys love this guy. So I have cosine squared x plus sine squared x equals now. And then if I wanted to get tangent, I would have to divide both sides by sine. No, not sine. Cosine squared x. And if I divide both sides by cosine squared x, I get secant squared x. And on this side, I get that divided by that, which is tangent squared x. And then that divided by that, which is now. Okay, so what? If I take this out, what do I put in there? If I take him out, what do I put in his place? I put tangent squared x plus 1. And then there's a minus tangent square or tangent x equals quattro. Before I factor this, I need to make sure that this is equal to 0. So I have to subtract 4 from both sides, and now I have tangent squared x minus tangent x minus 3 equals 0. And once you get that, you can factor this dude. I have like that squared plus minus 2 that, and then negative 3. What times what gives me negative 3, but adds to give me negative 2? And 2 says? That's right, negative 3 and positive 1. Man, you guys are so good at this. All right, so we got tangent x and then tangent x. So beautiful. Once you get two factors that multiply to equal 0, you can set each of those factors equal to 0 and solve it. Let's do this first one really quick. I'm going to add 3 to both sides, and then, oh my goodness, we have tangent x equals 3. If you guys thinking about your unit circle, where does tangent x equal 3? Nowhere obvious. Nowhere obvious. Okay, it's actually somewhere right here, but it's not a common angle, so we can't solve this without a calculator. So you know what you do? You say x equals arc tangent. You wish it was no solution. Arc tangent of 3. That's it. You're done. Oh, wait. We got to add the period to it. What's the period? What's the period of this tangent? It's just pi. So I'm going to add pi n. Boom. Okay, so there is part of your solution. Okay, let's do it with the other guy. The other guy, if I subtract 1 from both sides, I would get tangent x equals negative now. Where is tangent equal to negative now? You guys know probably that the coordinates right here are rad 2 over 2 and rad 2 over 2. And if I divide those, I get now. So where would I get negative now? Would I get it right here with a negative rad 2 over 2 and a negative rad 2 over 2? If I divide those, do I get a negative now? No. Yeah, in the second quadrant and the fourth quadrant. The second quadrant would have negative rad 2 over 2 and then positive rad 2 over 2. And since we have a positive and negative, when we divide those, we end up with a negative rad 2 over 2 and then negative rad 2 over 2. Dang. So the question now is, what is this angle? You know that this one is pi over 4. You know that this one is 2 pi over 4. This one is what? 3 pi over 4. So 3 pi over 4 is my angle. So that's my answer. X equals 3 pi over 4. What's the period for the tangent again? Plus pi n. Now, you'll notice I'm not going to waste my time finding the angle of that one because that is exactly pi away from it. And so I would be being redundant by naming that one as well. So those are my two solutions. All right, I just want to clarify this a little bit more because somebody asked, how come we're not going to name this angle right here? Right? That's what you're saying? Okay, that angle would be 7 pi over 4. Okay? That would be 7 pi over 4. How come we're not naming that? Well, check this out. If I had 3 pi over 4, and I add the first pi to it, okay, so we're pretending that n equals 1, so we just have 1 pi. If I add 1 pi, that would be the same as going 4 pi over 4, right? right? Okay, so what is 3 plus 4? 7, so I have 7 pi over 4. So this answer actually includes this. I don't have to write it.